Hey students, so on this clip we're going to be going over 3 examples on how to convert angles from fixed to radian measure, and then we're going to go ahead and graph them and find the reference angles. Okay, so let's go ahead and write down the instruction for the notes of what we're going to be doing today. So write down the following: express the given angle theta, given angle theta in degrees and radians. Okay, graph in standard position, indicate the quadrant of the terminal side, and find the reference angle. You're going to find the reference angle in degree and radian form. And radian angular measures. Okay. All right. So let's go ahead and take a look at question number 1. For question 1, the angle under consideration is theta equals 300 degrees. Okay. Now, since this is expressed in degrees, we have to express it in radian form, and then we can then write theta in degree and radians. So in radian form, we have to multiply 300 degrees by a conversion factor. Okay? So the question is, am I going to multiply 300 by pi over 180 degrees or 180 degrees over pi? Which of these do I multiply 300 degrees by to change it into degrees? To change it into radians. Now you notice that degree 300 has a degree on the numerator. So whichever one has a degree on the denominator, that will help cancel the degrees and change it into radians. So this is the option that we're going to pick. Alright, so we're going to multiply it by pi radians over 180 degrees. This is a good option because it has degree on the bottom. Notice what happens. Put this over 1. The degrees and the degrees divide out. Now you're left with radian. Okay? So what you do is you multiply across. You have 300 pi over 180 radians. Okay? Now, you notice the zeros divide out. So divide by 10. Now I can divide 30 over 18 by 6, okay? If I divide the numerator by 6, divide 30 by 6, I'll have 5. And then if I divide 18 by 6, I'll have 3. Alright, so that whole thing becomes, this whole ratio becomes 5 pi over 3 radians. Okay? Alright, so theta expressed in degree form and degree and radian form, we're going to write theta equals 300 degrees or 5 pi over 3 radians. Okay? Alright, so there goes our first answer. Now what we're going to do next is we're going to graph it. Alright, let's go ahead and graph it. To graph it, I like to use the degree form to graph because it's much easier to graph. So let's create our coordinate system. There goes my x-axis, and there goes my y-axis. Now, this is positive 300 degrees, right? Positive 300 degrees, so we'll start from 0. Positive rotation means you're going to be going up. Okay, that's positive. If it were a negative angular measure, we'll go the other direction. Okay, so don't forget, positive is counterclockwise or up, negative is down or clockwise. All right, but we're going up this time. So not quarter of a full circle. A quarter of a full circle is 90 degrees. So this is 90, or pi over 2, but just stick with degrees there. Okay, so 90, two small, keep on going. Add another 90, 180. Two small, keep on going. 270. Add another, keep adding 90s, okay, until you get bigger than this and you back up. All right, so this is too small. Add another 90 to 270. We have 360. Oh, that's too big. So 300 degrees is between 360 and 270 degrees. So our terminal side is going to be in this quadrant right here. Okay. So let's go ahead and indicate our angle. The region that the angle swept started from 0 and went round to here. That makes this terminal side right here 300 degrees, or 5 pi over 3. Okay? So this is our theta right here. Okay, now we have theta and the graph. Now we have to find the reference angle. All right, so let's indicate our reference angle on the graph and then find it. So this angle, the angle starting from your x-axis, the closest x-axis to the terminal side, indicates your reference angle. Okay, you can't use this x-axis because it's too far from the terminal side. This is the closest one. Okay, so this is going to be theta reference. That's the reference angle. All right. So now what we're going to look for next is the reference angle. Reference angle. Now, how do we find the reference angle? The reference angle is basically the measure of the angular distance from the x-axis, the closest x-axis to the terminal side. Okay, so this is 360 and this is 300. How many more degrees do you need to go from 300 to 360? You need 60 degrees, right? So reference angle is simply going to be, theta reference is simply going to be 360, which is this angle right here, minus 300, which is 60 degrees. Remember, reference angle is always positive, okay? So 60 degrees, that's in degree form. How do I express 60 degrees in radians? How do I express that in radians? So I'm going to go 60 degrees over 1. I want to multiply it by, remember like we did in the earlier part of the problem, pi over 180. So multiply this by pi over 180 degrees. Okay. The degrees cancel out. Multiply across, we'll have 60 pi over 180 radians. Divide by 0. Then when I divide the top by 6, I get 1. Divide the bottom by 6, I get 3. So that equals pi over 3 radians. Okay? So our reference angle, we're supposed to express it in degree and radian form, is 60 degrees, or pi over 3 radians. Okay, so that's reference angle in degree and radian form. Alright? So this angular measure right here is 30 degrees or pi over 3. Alright, last but not the least is the quadrant. What quadrant is our terminal side in? We know that this is quadrant 1. And then we label our quadrants in a counterclockwise fashion. Okay, 1, 2, 3, 4. So the terminal side is in quadrant 4. Alright, so quadrant 4. So theta is in quadrant number 4. Alright, so that's that. Let's move along to question number 2. In question 2, we have the problem. In this case, we have theta equals negative 760 degrees. Okay? So theta is in degrees in this problem also, so we have to express theta in radian form. Okay? So in radian form, we have to multiply negative 760 degrees by its conversion factor. Okay, so we have two options, either pi over 180 degrees or 180 degrees over pi. Remember, these two things are the same thing as 1, right? Because pi and 180 are equivalent measures. Pi radians and 180 degrees. So which of these am I going to use? Well, since we have degree on the top, whichever one has degree on the bottom will be the correct choice. So the one with degree on the bottom is this one right here. So we're going to pick this formula as our conversion formula, okay? Just like we did in question number 1. So we have pi radians over 180 degrees. All right, so you notice what happens is that the degrees divide out. Now we can multiply across. And then we have negative 760 pi radians over 180 degrees. I mean 180. Okay, this is radians. The degrees already canceled out. Now the zeros divide out. And what goes into 76 and 18? We know that this is an even number, so I can divide top and bottom by 2. Okay, so when I divide 76 by 2, divide that by 2, I have 2 goes into 7 3 times, and then 2 goes into 16 8 times. All right, and then 2 goes into 18 9 times. So the answer is going to be negative 38 pi over 9 radians. Okay, so theta is going to be negative 760 degrees or negative 38 pi over 9 radians. All right, so now we've expressed it in degree and radian form. We're now ready to graph. So let's go ahead and graph, okay? Graph. All right, so to graph this, we'll make our coordinate system. This goes our x-axis. I mean our y-axis and the x-axis. Now note that our angular measure is negative. So what does that mean? It means that when we start from 0, instead of going up, we're going to go the negative direction, which is down. All right, negative and counterclockwise rotation are both in the same direction. Okay, so when we're numbering our angles, we're going to be going down. So every quarter circle means negative 90 degrees. Okay, so first quarter is negative 90. Too small, keep on going. We go again. Another quarter, negative 180. Too small, keep going. Negative 270. Keep subtracting 90. Too small, keep going. Negative 360. Too small, keep going. Negative 450. Too small, keep going. Negative 540. Too small, keep going. Negative 630. Too small, keep going. Negative 720. Too small, keep going. Negative 810. Oh, that's too big. We gotta back off. So that means negative 760 is going to be somewhere in between these two axes. Okay. So we're gonna draw our terminal side like this. All right. Let's indicate our angle of rotation. Okay. So remember how we went about this? We started from 0 and we went around one full time. That was enough. Went around again, and then we ended up here at 720. Okay, so let's indicate what we did. So we started from here, went round. 360 wasn't good enough. We had to go around again. 720, bam. That's what theta is. All right. Try to make it as circular as possible. Mine is kind of weird, but you get the drill. So that indicates how we rotated to end up with what we did. All right. So this right here is theta, and theta is negative 760 degrees or negative 38 pi over 9 radians. All right. Okay, good. Now we have the graph. Now let's indicate the reference angle and find it. The reference angle is an angular measure to the closest x-axis. So from the closest x-axis, this is the closest one right here. So that's theta reference, okay? We can't use this one because that's too far. It's closer to this, so we use this one right here. All right, so what is the measure of that angle? Well, let's write that on the side. Reference angle. Reference angle. Now, we're going from 720 to 760. How many degrees is there from 720 to 760? So to find it out, we just subtract the bigger one from the smaller one. 760 minus 720 and that gives you 40 degrees. Now you have to note that the reference angle is always positive. Okay, the reference angle can never be positive, negative. So theta reference is 40 degrees. Is 40 degrees in degree measure. What is 40 degrees as radians? So we have to find out what it is. So 40 degrees will multiply by the same adjustment factor, conversion factor like we did before, which is pi over 180 degrees. All right. 30 over 1, the zeros divide, the degrees cancel out, and then we can multiply across, and we have 40 pi over 180. Okay, divide the top and bottom by 10, so the zeros divide out, and then now we can divide 4 by 2, which is 2, and divide 18 by 2, which is 9, and then your answer is 2 pi over 9 radians. Okay, so what did we just find? This is the reference angle. So theta reference is equal to 40 degrees or 2 pi over 9 radians. Now that we have our reference angle, what quadrant is this in? So this is going to be in quadrant number, let's see, what quadrant is it? Let's see, so this is how we label our quadrants. We start from the first one. This is 1, 2, 3, quadrant 4. So it's going to be in quadrant number 4. All right, so there you have it. All right, let's go ahead and take a look at one last problem. Question number 3. Question 3, we have 7 pi over 3 radians. Okay. All right, so 7 pi over 3 radians. Let me write this again so that it doesn't look confusing. 7 pi over 3. All right, so for this one, what we're going to do is convert it into degree measure. Okay, so in degrees, what is theta? Well, we have 7 pi over 3. Now we have to multiply by either pi over 180 or 180 over pi. One of these two will help us establish a conversion. So let's put degree here, degree here. So the one that has the pi on the bottom, that's the one that we're going to pick, okay? So that this pi cancels out. So which one has pi on the bottom? This option works perfectly, okay? So we're going to multiply this by 180 degrees over pi, because that's the one with a pi on the bottom, okay? So the pi is divide out, pi radians divide out. So we're going to be left with yeah, if you notice, 3 can go into 180, right? So let's divide that so I don't have to multiply big numbers. So 3 goes into itself once, and 3 goes into 180 60 times, all right? So multiplying that across in the numerator, we'll have 420 degrees, all right? So that tells me that theta is 7 pi over 3 radians, or 420 degrees. All right, let's go ahead and graph this, since we already have the angle expressed in degree and radian form. So now we're going to generate the graph. All right. Okay, so let's make the graph. Draw a coordinate system. We have our y-axis, and then our x-axis. Now we have a positive angular measure, so that means we're going to be executing a counterclockwise rotation. Remember, positive means you're going to go up and across, over, so that's positive. If it were negative, we'll go clockwise, all right? So every quarter circle is 90 degrees. So when we exceed 420, we have to back up, okay? We'll know exactly where we're at. So 0 quarter circle, 90 degrees, too small. Add another 90, 180, too small. Add another 90, 270, too small. Add another 90, 360, too small. Add another 90, 450, Uh-oh, that's too big. That means our terminal side is going to be between these two sides, between 450 and 360. So let's draw our terminal side. So this is our terminal side. Okay. Now let's indicate theta by showing the region that the angular region we swept through to end up with this terminal side. Remember, started from 0, went round, full circle, and then an additional angular span to get to this terminal side. So let's indicate that. So starting from 0, we went round, full circle to 360, and a little bit more. All right, so that's theta. And that tells me that the terminal side is 7 pi over 3, or 420 degrees. All right, now let's indicate where the reference angle is and find out what the measure is. Okay, so this angle, the measure of the terminal side to the closest x-axis is your reference angle. So this angle right here is your theta reference. Let's go ahead and find out what the reference angle is. All right, so let's write it on the side, reference angle. Reference angle. Now to find the reference angle, all we do is we go from this side right here. Ask ourselves, how many degrees does it take to go, how many degrees is the difference from 360 to 420? How many more degrees more do you need to go from 360 all the way to 420? So that's just elementary subtraction. So to find a reference angle, we're just going to subtract 360 from 420. Okay? If we do the subtraction, we'll end up with 60 degrees. All right, so that's what our reference angle is going to be. Okay, so but that is the degree measure. But how about in radian measure? So to convert this to radian, we'll go 60 degrees times the conversion factor is the one with the degree on the bottom, 180 degrees on the bottom to match this degree, and then pi on the top. Okay. Now let's see what happens here. The degrees divide out. You can multiply across. We have 60 pi over 180 radians. The zeros divide out, and then 6 divides into itself once and divides into 18 3 times. So it's basically going to be equal to pi over 3 radians. So that tells me that theta reference, my reference angle, is 60 degrees or pi over 3 radians. All right. Okay, now that we have a reference angle, let's find out what quadrant we're in. So the terminal side is in quadrant. So theta is in quadrant number 1, right? Quadrant 1, because this is quadrant 1 that the terminal side is in right there. So the theta is in quadrant number 1. All right, so there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel by clicking up here. More collection of clips can be found on mathgotserved.com. Thanks again, and have a wonderful day.